Hi, everybody. Welcome back to Code Talk Teach, our kind of technology talk show here at Oasis Digital, where we all work. I am Kyle Cordes. Let's go around and introduce.
Paul Spears.
Lance Finney.
Chris Harden.
And our main topic that we'll get to in a few minutes this week is we're going to talk primarily about the team collaboration aspects of how client systems and server systems talk. So how APIs are designed, how they're evolved over time, how they're specified, how they're tested, all of that. But as we always do to give people a little bit more time to arrive, we try to chat about any sort of smaller topics of the week. So Paul, before we started, you were talking about the kind of big move seems to be underway toward highly capable online code editing tools.
Yeah, it just seems like there's lots of competitors in this space that all have their own little take on like what are the most important subset of features, and they're all doing really great stuff, but just wildly different like designs and expectations from each of them.
Did you see the GitHub variant that was getting a lot of attention a week or so ago?
Yeah, is that the one that they introduced the new mobile experience on?
I don't know if it's the mobile experience, but basically when you're on almost any GitHub repository, you can modify the URL slightly. Does somebody here know for sure? Maybe test it on the side. We don't want to tell people
Well, you don't even need to modify the URL. You just hit the period key.
Okay. It's github.dev is the older way to do it. So if you change your github.com to a github.dev, or you just press the dot key, it brings up, I guess, current master of the current repo you're looking at in a sort of subset of Visual Studio Online, which is pretty cool, pretty slick. Now, when I last looked at this, there was not yet a way to have a terminal. So GitHub's variant of this is just to look at the code. You can't run any code. Since you can't run any code, you can't really do anything particularly useful with it yet. But I don't know. I was thrilled to see it so readily accessible in GitHub. Is it inconvenient to look at this code in a in a web page where you're scrolling a list of files? Press the period key, and now you're in something that's like 70% of the way to an IDE. And Paul, you were mentioning something about Stack Blitz also?
Well, yeah, like Stack Blitz is like particular subset and niche that they're working on. They're working on like bringing Node to the browser in a like plausible way through real development. And that's
I
getting,
saw it.
getting lots of
Very
attention. That's kind of
slick.
It's starting to elevate them
So
to like the national stage of competitiveness with other tools of this ilk.
And so they, I guess they compiled the Node source code to WebAssembly and ran it in a web worker. I think that's what that's one of the announcement posts said, something along those lines.
Yeah. So they took the JavaScript runtime that was ported to OSs and then ported it back to WebAssembly, and they have this like virtual file system.
So the really slick thing about that they seem to have worked out, although it seems like it might take a while to percolate through the ecosystem, is that you can make a WebAssembly compilation of native tools, and as long as like the API of the native tool is the same, it will work. And so if you have like a native code compiler that you want to use, in one of your Node modules, normally, of course, that wouldn't work, because if it's, Intel assembly code. But if you can provide a WebAssembly compilation of it, it'll actually work inside the Stack Blitz Node-like environment inside a web worker, which is very slick. So I guess my main question that always comes up when I see these tools, Stack Blitz and literally 100 others, is I wonder how big of a project you can work on in them. I know that, maybe in an ideal world, we would all do a great job making our projects divided into many small sub-projects and never have to like open up all the code at once. But I know also on many of our actual projects, we help customers with, they sometimes have quite a large amount of code that always gets opened at once in the IDE. And I'd be curious if anybody out there is doing some sort of bake-off where they're taking large projects and try to open them in the top 10 online IDEs and just see to what extent they'll work. I don't know. I think it might be surprising how much. Yeah, go ahead.
Well, I mean, there's this move toward, sort of mini monorepos. So, I mean, I pretty much use Nx for everything and break stuff up into little apps. And so how does that work with trying to move towards online editors, which seem to be focused on one app at a time?
Yeah, that's what I was getting at. If you're doing a monorepo that has, or even a not quite monorepo, but just a really large project has a lot of code in one repo, even though you're only going to work on a little bit, if you kind of have to open the whole thing, that could put strain on your development environment. I don't know. I can imagine a case where one of these tools could integrate with a monorepo tool, like say NX, and integrate in a way that lets it avoid loading all of the code into the browser environment at the same time. But that's just literally, I'm imagining that it's possible. I have absolutely no idea if any of them is even considering that kind of architecture. But it seems possible.
I think it like on a completely different axis, Code Sandbox, like they're working on their mobile story, which is
nice.
like how small of a device can you code on at all? And they got a pretty slick version of their editor now. It strips out all the code, the chroming of a page, and is like just drops you right into this really slick editor experience. But it's on a phone.
I guess they would have to run most of the environment on the server side to do that, right? I mean,
I think that's still the approach Code Sandbox takes for their build stuff.
What is really the use case for that?
I mean, I think that we might all be outside the demographic that use case is for. I would observe experimentally that below a certain age cutoff, people seem to live almost entirely on their mobile device. I can kind of imagine some people, if you could make it work well enough, pulling out their phone and coding, which, I mean, it sounds completely crazy to me, but I can still imagine it happening.
Well, and I think it actually also like organizationally trickles from the top down. You've got like, theoretically, the higher up in the org chart you are, like the less time you actually spend sitting directly in front of a computer with time to stand up your whole environment and dig in and work optimally within a code base. Having someone who's like reviewer and project manager of several projects at once, being able to have one project up over here and then quickly, submit a PR comment, on your phone, like there might be some power behind that idea.
My wife will be so happy if I can do PRs from the restaurant or when we're out at my in-laws, or she'll be so happy.
Right.
I have repeatedly wanted on my phone to be able to read a commit and then write a comment on it with the voice dictation that my phone will do. And I've been stymied because Bitbucket, which is probably the tool we use, we use several, but it's one of the more popular ones we use, it's not good at that at all. It has the Bitbucket page for looking at a commit is very, very heavy. It tries to load a tremendous amount of DOM onto the page, and it is completely, like, its responsiveness is really, really bad. And it doesn't do any kind of like incremental loading. So if somebody has a commit that has like some kind of junk file, has 1,000 lines you don't care about, you just can't even open the page on your phone at all. But I think that's just because they haven't been targeting that. I can imagine somebody targeting that use case and making a very usable code review on my phone. I don't know. I would use that. I would do code review on my phone. I might have the same sort of ire as Lance mentioned arise in the household, but I would totally do it. Well, anything else before we jump to our main topic of the day? Okay, well, I wrote the little set of bullet points, so I guess I'll kick them off, but that also means that if the bullet points are woefully deficient, it's my fault. So our main topic is I wanted to talk about the collaboration that has to happen between, I guess, any team of more than one, where there is a user interface and a back end, a front end and a back end, a UI and a server, whatever you want to call them. Like, how do you handle building and then iterating over time on these two parts of a system talking over an API, when there's also have to be two humans or two groups of humans, or maybe more than two groups of humans, talking about the same API? The sort of the flippant answer from the early agilists was, well, you need to have one team, not two. And I think that's generally kind of good baseline advice. Have one team, not two. But that's my first kind of question, is like, what do we see in the wild? What have we seen work well? What have we seen not work well in terms of dividing up front end, back end work between, the same team, more than one team? Then we have some other notes to work through here that I guess we'll keep to ourselves as we get through them. But I think that's a good starting point. So somebody want to weigh in on your experiences and thoughts?
I don't think there is one answer, because what will or won't work varies greatly based on the skill set of your team, whether or not you're doing, say, microservices with multiple apps. Like, there's so many factors that any one of those answers is correct in some situations but not in others.
So okay, well, let me ask it differently. How big can a team get before you have to divide it up into different teams to work on the server half of the system and the client half of the system?
That question kind of routes us in a different direction, knowing that assumes that is the appropriate, that a horizontal split of the teams is appropriate.
Like a feature split or a domain.
I didn't mean to assume that. I was sort of saying at the extreme case, right? If you have a team of 10,000, they're probably divided on like every possible
and technology.
Right. But I'm saying, like, in the simplest case, that you've decided the only way you're going to divide a team is into this group is working on the UI and this group is working on the services. What do you think is sort of the point where you just would absolutely have to make that split if you've already decided that is the split you're going to make?
I would only do that if the people that I have to work with are really only, if their skill sets are limited to one or the other, right?
Yeah.
Like, it seems to me an extreme situation. Like, okay, if you can only really do back end well and you can really only do front end well, then yeah, let's split the teams that way. Otherwise, I wouldn't do that. I would totally do it more based on a feature area or a domain area and have people take more vertical slices per team.
Yeah, we have a viewer comment here. And I, of course, agree completely with the comment here and with you, Chris, that my bent would always be by default to slice vertically by feature, not to slice horizontally until I absolutely had to.
I have another couple scenarios. Oh, go ahead, Lance.
I was just going to say something that I've run into in the past. Sometimes the front end team is in the United States and the back end team is halfway around the world. And then, that's just, the company is big enough that is how they divide things up. And you run into issues there where just the collaboration is going to be different if you're not, if you're not even in the same time zone that you can work with. There are certain collaborations that you can consider if you're co-located, or at least, you can get on Zoom together most of the day, that just don't work when half the team is in India or something.
So it seems to me that I'm going to cite our one commenter so far and the four of us. So that's 5 out of 5 seem to suggest that slicing a team along the client-server API boundary is probably not the right default way to do it, certainly, and is generally, maybe pretty far down the list of good ideas in terms of how you divide a team. And then Lance brought up that, we see companies that I think they conclude, for maybe reasons, I don't know, maybe people can propose reasons here, that the geography of their development team requires such a split. And then Chris suggested that the sort of technology experience of each developer maybe leads to such a split.
Yeah, and I've got a couple other points for, like why you might make that divide also. One of them is that you'll often see companies like staff a project in a very front-heavy way. At the very beginning of the project, you've got 10 developers that you're responsible for like putting to work, and you don't have an app yet. You don't have a front end or a back end app yet. And one of the points we talk about this in Angular for Architects a lot. One of the ideas that I go back to in that class is the idea of surface area. And like the only way to keep a number of developers busy is you have to have a large enough surface area of your project like already done before you can add more people to it. And this is an easy artificial way to increase that surface area, is to say, put one group of people busy on the back end creating that app, fleshing out the structure and the architectural patterns of the back end in parallel with the front end. So that's one area where I see that appears to be a wise decision. And another one is like the perception of progress is like a very huge thing. And it is really easy to create an increased perception of, perceived rate of progress if you have two teams of people working on small iterative chunks, even if those chunks take you actually in two opposite directions rather than, a singular goal. So I see those as like other factors of that lead people towards making the decision to split front and back that have nothing to do with the technology.
Yeah, along with what Paul said, I mean, there's also as you were kind of alluding to the different stages of the project. So like, in the beginning when you're like building the server side from scratch, you probably do need some dedicated people thinking about architecture and all that and getting something going. But like kind of later on when you're like adding a feature to an existing app or front end app, then it kind of makes more sense for, one person might even just go in and like add a little bit of code to the server, add one REST endpoint, add the UI feature. And so it kind of differs based on where you're at in the life cycle of the project.
So here's a random idea that what you said just kind of sparked. Like, what if instead we created teams that were like a front-end architecture and a back-end architecture team supported by full-stack feature developers? It's like you only split the architects, like to do the most important, like establishing the boundaries and the rules, and then like expect your feature developers to work full-stack across them, getting help from the appropriate architecture teams.
I mean, I think that probably is a pretty good characterization of our default mode of working. So in projects where we're engaged to go build a thing, I think we tend to say, well, I mean, almost by definition, the more experienced people here are the people that you'd call an architect. And those people go define and get up and running an end-to-end working system. And then other people who are experienced but not as experienced are working full stack, implementing features across that architecture. We don't always work in that mode. We very often are jumping into our customers' existing solutions and systems and helping them. But Paul, I think what you described is pretty much exactly how we launch by default.
I feel like, so I mean, Lance and I worked together at a different company, and I feel like that what Paul said is kind of what we were doing there. Like there were multiple architects for the entire project, but I was like the web-focused architect, and a different person was the server side. But yeah, whenever Lance and I were adding features to the UI, we were responsible for going in and doing the full slice of that, but we didn't have the responsibility of worrying about the whole gnarly server side and all the other details. And I feel like that worked pretty well.
Well, for added bonus, there's also the companies that when you say front end, they actually mean the people who write the application server code.
Yeah.
Because to them, back end means like a whole nother team dealing with database and the actual like hardware and server setup.
Yeah.
Naming is hard.
Yeah.
Right. There's different layers, and depending on the slice you're looking at, you might call this the front end and the back end.
Yeah, because of the projects I've been on recently, when this even came up, I was assuming the front end included the nest layer, because the Angular team that I was working on was writing that, and the backend for the Nest layer were all of the data APIs. And so there wasn't really a difference between the front end team and the back end team in terms of anything that was written in TypeScript, but all of those things providing the data, that was the back end that we had to negotiate all of the APIs. And that was a completely different team because it's really a whole different set of skill sets.
So this is actually in our outline of topics to discuss today, but it's pretty deep in the list, Lance. And the scenario you're describing, I've heard this, I've done this, but I've heard this named as the idea of a facade. So a back-end system, especially a large, sprawling, partially legacy back-end system, or a hot new microservice back-end system, often ends up in a state where to perform any kind of operation that a user cares about, you need to orchestrate multiple bodies of code, multiple services running in different places, multiple data stores, multiple chunks of code of all kinds. And sometimes it makes a lot of sense to build a sort of facade server, a server whose job is to be the back end for one or a small group of user interfaces, but then it serves as the front end of the underlying deeper in the back end data-driven systems that are being operated. Now, I think that probably right now most of our customer projects have an architecture that is at least some variant of that. And I think there's a pretty compelling argument, even if you have divided the team front and back, for those deep back-end services, to have the same group of people working on that facade server as who are working on the user interfaces that call it. Is that an accurate description, Lance, of your experiences?
Well, I mean, what I remember for the project I'm thinking of in particular, there was a team that we were supposed to be working with. Unfortunately, the abstractions leaked, and we often ended up, we'd have a problem, and they'd say, well, it's not really this level, it's actually the lower level. And so we ended up getting involved in all the layers, even though there was supposed to be a facade that that would handle all those issues. And maybe that was, there were specific things that could have been done to fix it, and maybe it was inevitable.
I mean, the nature of abstractions is to leak.
Yeah.
I mean, and that's whenever you have a group of services or, some sort of back end, the people maintaining it, they're maintaining something that's used by multiple different clients or applications for multiple reasons. And so a lot of times they're trying to, they're trying to figure out what is going to be, the most generic, most common thing, but they don't necessarily have all the information they need to get it right. There's always going to be some part that doesn't quite get it right. And when an application goes to do a particular use case, there's going to be something missing or something that needs to be changed, because you can't make a perfect service that's just universally usable. It's just not possible. You don't have all the information, all the requirements.
So I think what ties into that is, given the uncertainty that is always there as you're starting to build a system, what are the options, the trade-offs, the reasons to start building the servers part first and then figure out how to put a UI on it? Start building a UI first and then figure out what services it's going to need. Start building both and then work out how the API is going to work once you've built them both. Or to start by building the API, and then once you have defined the API, stop building the UI and the server in front of it. I think I've sort of tiled the space, at least for the case of two adjacent layers. I think that sort of tiles the space. Of course, it's the combinatorial explosion of possibilities if you have more than two layers.
I think one of the things you have to consider is, what is the difficult part of the project? Where's the failure going to be? Because it could be that it's figuring out a good user interface, a good user experience, or compelling user experience, and then that's probably where you want to start. But it could also be, well, we're working for a corporation that just bought 3 subsidiaries, and our project is to combine their data in a way that has never been done before. If we're doing that, then trying to get the data, to figure out if the data even can be combined, has to be done at least early. Like, it doesn't matter how pretty your UI is if it turns out that the backend data systems can't even talk to each other.
I think that idea. Go ahead.
I was just saying, it's like what he's saying. Just to rephrase it, is like kind of looking for the area of greatest risk, and then just tackling that part first.
Yeah.
Yeah, I like the. Sometimes I've described it as like there's a certain amount of innovation budget every project has, and if your project's idea is we're going to think of a whole new way for user interfaces to work, and we're going to pick up a whole new language for writing user interfaces, and we're going to use a new kind of API that's never been invented before, and we're going to use all new server-side infrastructure to implement that API, you better have a truly tremendous innovation budget. Most real projects don't have that unlimited ability to innovate, and so they typically say, well, we're going to build a server side in a way we're pretty familiar with, and we're going to use tools we're pretty familiar with, but we're going to do this, like Lance, you're saying, we're going to do a new kind of data integration we've never done before. Or, yeah, we have the same data. The data in our system is pretty great, but we need a new kind of UI to visualize that data, to make it more actionable. So I think this idea of figure out where your innovation is going to be concentrated, and then probably start by working on that part first. If that's where the risk is, that's where the hard part is. It can be very tempting to go do the easy part of a project first. I'm sure I've been guilty of doing the easy part of a project first, but I think that's a really good way to have your project utterly fail to meet expectations, if you start with the easy parts and then defer the hard parts forever.
Yeah, years ago I worked on a project where they got a big team of Java developers together. Most of us were pretty junior Java developers. This was 20 years ago. And we billed a lot of money for quite a few months before they realized that the data that they thought they would need to bring was actually going to be like multiple megs, and the networks of the time couldn't handle it. And so it just, the project failed, not because the UI hadn't made any progress, although we didn't make that much, to be honest, but because they just, the back end could not give us what we wanted because of the constraints of the time.
Was it a constraint that the UI being imagined simply needed more data than could be delivered to it? Or was it a constraint of somebody couldn't figure out how to do the work on the back end, so they had to shove it over the network?
I honestly don't remember the details. I just remember that kind of the final straw for the project was, this thing that we wanted to pull over, and the users wanted it within X seconds, was going to be Y megabytes, and it just couldn't happen. I don't remember the details beyond that. It's been long enough ago.
Yeah.
So Kyle, one of the permutations that you had mentioned there about that those aspects of collaboration, one of them that I personally get irritated with whenever I encounter it is when we start up a brand new project and decide that the backend is going to serve as the general purpose API for everyone, as well as the API for our application.
Mm.
And then furthermore, they put different teams on the front end team and back end team.
Yeah.
Because what you typically find in that particular scenario, you create this perfect storm of the project manager for the back end. They're tasked with the more generic job of making a general purpose API, and like they happen to be somewhat tertiarily aware of the fact that your client project happens to be one of the first clients, but they're still aiming to make it a general purpose solution. And so like all of the developers on that team are like working at a breakneck speed to like do things that don't help you, and at worst case, they're like actively work against you while you're trying to like get anyone on the phone to like just change the payload of a data object just a little bit to like prevent you from doubling your work in the front end.
Yeah, a lot of that also goes.
Go ahead.
Well, I know that one of your later talking points was, like traditional, like just CRUD, basic CRUD API versus a more specific API. And I think that also comes into play there, because the way you make something super generic is by following these hard set rules of, oh, we're going to make it a REST CRUD API and not do anything, that it doesn't say in the wiki article for REST. And then that's almost always too inefficient for the UI.
So a fairly this is like another common failure mode, right? To build a fine-grained, very generic API that you then want to put a like business process optimized front end on. You can end up like sort of writing core business logic of a system in your user interface, which, although there are cases in the development world where you want to do that, they're relatively few and far between, at least in the sort of business application system we work on, where you really don't, as a company, want to have an API such that the business rules are implemented inside an Angular service, inside a front-end system that calls that API, right? Because now the business rules are not going to be implemented consistently, either over time or over different applications.
Right.
Yeah, so you solve the problem by doing all those business rules in a nest service, just one layer down, and that solves everything.
I mean, doing them in a facade is not as bad as doing them in the UI.
Yeah, I know. It's better.
But the problem with that, though, is still is in performance. And again, it depends on the structure of your data.
Yeah.
But if you have, complex relational data, which, it does still exist, you can't come up with a REST API that handles that particularly well. Because, it's like, okay, if I'm following the strict rules of REST, I'm going to get this one resource. Like, well, it's actually a table that has relationships with 10 other tables. Well,
yeah.
How far down that tree do I go when I bring back this document? And so it's like, is the client going to have to issue, or even the facade, you're going to have to issue 5 requests for something that would have been an optimized table join,
There are so many systems, and like, I don't want to speak ill of anyone doing microservices, because I've done microservices and they have some very cool advantages. But there are so many systems out there that have basically taken what is relational data that has a lot of inter-entity constraints, and shattered it into a dozen microservices, and then had facade or even user interface layers performing joins and data integrity checks across it. And that is immensely, I would describe it, it's technically frustrating, but that's the sort of system that you really don't want to be the person paying for. Because you'll wake up one morning and realize that you have spent 10, 20x what the budget should have been for the functionality being provided by the architecture that was chosen to implement it. We have just incredibly well-proven, long-proven, highly efficient, reliable, robust systems for dealing with data that has a bunch of relationships between the data and needs to query across those relationships. Like, this is
that is also scalable.
Problem. Yeah, and also
that is also scalable, redundant, failing over properly,
cacheable, ready to ship to the cloud, extensible. Yeah,
for that you turn on switches rather than build that functionality by hand.
Right. You're like, you know what? My joins are not running as quickly as I want. Let me do a quick 1-hour consultation with someone who's an expert in how joins work on the data layer I'm using, and they'll help me make a few adjustments, and now it'll be 20x faster with like no lines of code written. I've had really great results building systems on relational databases. Not to say every system should be on a relational database. Many systems should be partially on a relational base. If a system has a certain aspect of its data that might scale to the moon, but then many other aspects of the data that fundamentally are never going to be, more than 1 million entities or something, it still may make sense to implement a portion of the system in a very straightforward way, and then to have a different kind of API talking to a different kind of scalable backend system for the one kind of data that there could be a trillion entries for that you wouldn't want to try to put in a relational database.
This is getting off into a whole other another show. It's like,
Oh, we could talk.
Well,
Yeah.
listening to like all the different permutations of this particular problem of like front end versus back end, it made me realize that we actually have like a very similar problem to this that is completely contained within the front end, and that is the relationship of the feature authors to UI component author teams.
Yep.
Like we're starting to see like, oh, we have the database team, the backend team, the front end team, and the component library team
Right.
that's starting to show up. And like interestingly, like I would say they're more like siblings to the backend team because they're another resource that the featured authors need to join together to create their applications. But we see the same mistakes being repeated over there of, that team is being tasked with, hey, go make this generic component set that is usable across the entire org. The manager put in charge of that is only slightly aware of the first client of that library, and they go off to make something that is, at worst, actually, counter the goals of the client that would end up consuming it.
Yeah.
So it's
I mean,
not necessarily a front end back end thing. Like as we zoom in, we see that this is actually like a multi-team problem in general.
It's a fractal.
Yeah. It's not quite recursion. We haven't gotten to recursion yet. Me and the show on recursion.
So for that zooming in thing, Paul, I think we've also seen this sort of question, the same split of do we make this functionality first, or do we make this functionality first, or do we make them both together, then try to tie them, or do we define the API and then go out from there? We see that happen between, say, the sort of back end of the front end, right? So like maybe you have some code inside of a React client app that's kind of implementing the essential logic, and then a kind of front end of the front end, which is like the visual appearance on top of it. And those can actually have that same question. If you have different teams, you have to figure out how are you going to interact around the relationship of those parts.
Yeah. Well, and like to answer your question of like how you go about tackling that problem, I think it was Chris who made a comment much earlier in the show about like the capabilities of the team involved. And like the more I do consulting based work, like the stronger that particular factor weighs in the advice I give. Like me personally, like if I were to put like our team of folks on like authoring and using like these kind of APIs, I would strongly lean into the idea of no, just have one team work on all of these vertical aspects like together and put a strong emphasis on a culture of refactor as you go. But that's because I know our company has a strong focus and discipline around refactoring as we go. And I wouldn't trust a company that has, junior developers or developers who have been doing like rote copy paste kind of development for years in their org. I wouldn't necessarily trust them to suddenly shift their development culture to something they've never experienced and expect them to pick up the discipline needed to be successful with that. So,
I mean, as consultants, right? This joke as a consultant, the answer is always it depends. The problem is that's the truth. The truth is also that the answer is always that it depends. So how should we build this system? Well, unfortunately, let me get to know your organization, your team, your teams, your goals, and then
your management.
And then eventually we can give hopefully reasonably well-considered advice on how to build this system. And on the flip side of that is be very cautious of taking any key advice from a blog post, a tweet, a page of documentation, a conference talk, a YouTube video, even this YouTube video. So many systems where systems is both software, hardware, and people have so much complexity that you really need to consider the specifics to make good decisions.
Yeah, and like I have a presentation coming up for a client that we're consulting for where they wanted a deeper kind of background in things like monorepos. They wanted to know more about monorepos, and having to revisit and rework my talk because like they don't need a sales pitch. Like they need someone to actually explain, like, despite my desire to use monorepos, like they need to be told, like, here's the trouble you're going to get into with monorepos. Here are the challenges and the skills that your team would have to have in order to be successful with monorepos. Like, maybe a monolith isn't a bad idea after all. Like saying those things that are not necessarily the hottest latest trends, but like, yes, for some companies, like just having one piece of software might be the right answer. But starting to stray
I
a
don't
little
want to
bit again
sound
from the
too
topic.
retro, but yeah. So our next really big topic, I have a slight diversion first, is going to be about how to handle versioning and change when you have a sprawl, multiple services, multiple clients, multiple teams working on them. But I had one more sort of small comment while we warm up to that one, and that is, I think it can really pay off to go write the part of the program that solves the actual problem that you're trying to solve as a business first. And to write that little chunk of code, maybe in a way that you don't even necessarily care about where that code is going to run. And if you can't figure out what actual problem the software is going to solve, then maybe some more time spent not so much on like software design, but on solution design. Like, what is the problem? What are we trying to solve? What is this program going to actually do that solves the problem? I think working on that more, both thought and then some code, can really pay off. It can really reveal what functionality should be on what layer of the system. What should the API look like? Where is the risk? What should we go implement first? I've had very good results with that. Also had tough discussions, right? Where if the answer is it's going to store some data, it's like, well, storing some data isn't really doing a thing. So if you're storing some data, you need to keep talking about, like, why are we storing the data? What computation is going to eventually happen with that data? Okay, so this big topic on our outline, versioning and change. So now if we think about, we're in the middle, not at the beginning, in the middle of a system. There's, a couple of client apps, a couple of servers, APIs that have been defined. Some of those APIs are very well suited. Some we're really proud of. Others are maybe early designs that are not so great. Some of the UIs are more actively maintained. Some of the UIs don't really want to be maintained. How do we deal with a change in a system that's going to require coordination for a back-end system, a front-end, maybe a back-end data system, a facade middle tier, one or more UIs, multiple teams, many people on each team? Like, what have we seen? What have we seen our customers be successful with in managing change? What have we seen be a struggle?
I kind of feel like the answer to the last question is everything.
Well, sure.
Yeah.
This stuff is hard, right?
Very hard. Yeah, I feel like every time I've dealt with this, it ends up being an ad hoc solution that works for a while. I'm excited to hear what the other people on the panel have as answers.
The only real answer I have is, one time when I was working on a system that had a lot of different kind of microservices, a lot, different apps that, anyway, they're all just REST APIs. So we did a strategy of putting, version numbers into the REST endpoints, and then, when we needed to make any sort of breaking change, then we'd increment the version number, and kind of write little transformers. So in your REST service, if the request came in to an older version URL, you'd run the same code, but you'd have like this sort of transformer logic to say, okay, well, we're now at 2, and that request was for 1. This is what I have to do to the result or to the request to make it both match the current code so I can process it and then give them an answer they're expecting. But yeah, over time, it's going to become harder to maintain.
Obviously, the answer is going to depend greatly on how much version skew is expected, right? In the extreme case, you can think about a public API, like GitHub. We talked about GitHub earlier today. GitHub has an API. Who knows how many tens of thousands or more pieces of software out there, open source and proprietary, rely on an exact version of the GitHub API. Making a breaking change is completely out of the question. But moreover, even if you make a non-breaking change that's versioned, the skew you can expect on a widely used public API could be years, could be many years. You might anticipate having to support version N of an API for 10 years in the more extreme cases. In the most extreme cases, some of the protocols that the internet runs on are backward compatible, reaching in some cases back to the 1980s, which is kind of astonishing. In the other extreme case, everything's in a monorepo and it's all deployed synchronously.
Yeah.
And you literally, if I make a change, when I deploy it, I'm deploying both the server and client of that change. And the version skew is on the order of seconds or minutes.
And to answer your earlier question, that is what I have seen as like the most successful for clients that I've worked with is when we can actually continuously deploy the full stack. And that there are industries where that simply isn't a possibility, but for those that can, like that's a really easy win for them to pick up. Like if they can continuously deploy, then just do so.
So I've worked on large-scale systems where we couldn't because of the nature of how deployment worked. And I'm guessing we would all agree that supporting old versions of APIs is sometimes necessary and often quite expensive. I think that there's sometimes, maybe it's like a bravado in our industry of, well, the right thing to do is to support that versioned API, and so we're going to do it. And I think really the question has to be, what's it going to cost? And Paul, you talked about a scenario where it's a very easy win for people can say, hey, we have a way to never pay that cost. And if you can avoid having to support versioned APIs, you are saving money.
Yeah.
Chris, what was your sense of like sort of how expensive, like in the time and money sense, it was in the scenarios you were talking about, where you have a versioned endpoint, you write some transformers?
Yeah, I mean, I'm not sure. I wasn't there that long. Like, it was just a couple years. Another thing we did was, these were all our own apps, so we put in a mechanism for tracking the usage, so that we just basically had a table where we would log, what URL they were hitting and basically what app was calling it, because you had to identify yourself. That way we could be like, oh, this is an app. We didn't even know this app was using this API, because that was a big problem too. You have all these tools and everything everyone's using, and people lost track of what the dependencies even were. So
Yeah.
that was kind of like, oh, hey, we can identify this thing and go upgrade it,
Chris, you want to come give my monorepo talk for me?
So the great thing about a monorepo is if you really are using a monorepo, you know that you have all the source code and you can search it. I think that's possibly the biggest payoff of a monorepo, having your search be reliably correct.
Well, and you can do static analysis of the dependencies relationships between your code bases, as opposed to creating custom maintained reporting tools that analyze the use patterns of your software
Yeah.
base in order to even have the answer to that
Right.
question.
Especially since certainly REST APIs are often pretty easy to just sort of figure out and call without any kind of library support. So even inside an organization, even if the team that develops a certain API publishes a client-side kit that makes it easier to call that API, if it's pretty easy to call the API without the kit, some clients are not going to use the kit. So even if you did like static analysis of all the code that depended on your kit for calling your service, there might be other clients that just weren't using the kit and were calling it but with a handcrafted HTTP operation.
So some hard lessons I've been learning recently is that if you can't afford the luxury of continuously deploying, and you have to support, ranges of versions, it is very tempting to like go at solving a problem of saying, well, we're just going to have to like push a breaking change here, and like force everyone to pick this up and to deal with that period where it could be broken. And no matter how true that might seem, that the world can afford that breaking change at the moment, it rarely actually is ever true. Like you're almost always better off providing a path of backwards compatibility, no matter how crazy the change and the scope of the change is. I'm finding that to be more and more true the more I do this. Because as much as I would like to not have to support that backward compatibility, no matter how much like the folks in management around you say that yes, we can totally just move forward with the new world and leave the old behind, I'm in the team of no longer ever trusting that statement.
Especially if it's ever been deployed, right? If the old
Right.
thing is deployed somewhere.
I've
So
gotta,
okay, so we have this sort of like caution. Paul, you have the caution, I have the caution. Chris sounds like she successfully implemented systems that exercise this caution of support the old version, do it in a versioned way. I've had past conversations, but I'm pretty sure Lance is on board also to how to do this. Hasn't said so yet, but I believe he is. We all know how to do this. I think we're all actually pretty good at this. Support the old version for a while thing. A question that I have had come up repeatedly, I've had it come up in the last couple of months, and I had it come up 20 years ago, is what is the commencement of when we must not break deployed systems with API changes? Like, if a system is still in alpha, is it okay to do breaking changes? If it's still in beta, is it okay? If it's still in development, it hasn't, the first real user has not yet touched this system. But maybe, our development teams are starting to diverge a little bit,
Yeah.
but no real user is using a system. Is it okay to just make a breaking API change and just, hey, everybody's got to fix the code on both sides of it?
I would say,
Obviously, if you have customers in the field on systems that have been loaded on spaceships, yeah, obviously you're well past the point you have to commence not making breaking changes. But what's the front edge of that look like?
I would say that the user is never who you think it is.
Yeah,
The person who cares is never the person that you think is going to care.
yeah,
Like it is always like people several steps earlier in the process that you never would imagined would know, let alone care about creating such a breaking change that end up caring. Like, it's one of those where a client was dealing with a situation where we had a MFE architecture, micro front-end architecture, and we were responsible for maintaining the shell, if you will, that wraps around
sure.
the products that we swap out between. And system was not in production, not even close to being in production. It would had to have been distributed and rolled out inside of hardware, like shipped to facilities and installed before it would ever be used by an actual user. And yet, we could not actually commit a breaking change because of all of the demoing and the progress that was being made against that the edge that would break. And we tried. This is actually the same story of where I've learned not to just assume it's okay to make that breaking change. We tried to push that breaking change through because from our perspective, no one's using it. No one will even know it's broken. It turns out, like, behind the scenes, there's entire teams of dozens of people who were, in fact, like, using a unique, development environment that they ran into this breaking change just right, in just the right way, and it completely stopped a product team from shipping their business app. And it's just, this was not even in a testing environment yet. It was still literally just in the dev environment that this occurred.
I've had a version of that happen. Names omitted to protect the innocent, where early on, version N of the deployment platform was just picked up to start experimenting. Team picked up, node 6 or whatever it was at the time. And then downstream from there, an operations team saw, they were never like formally told, a decision has been made. The system to be developed later this year will be on this. No, they noticed, they just happened to see a prototype. And they went and did a bunch of work that sort of like locked in the exact node version that what they thought the whole thing was going to be deployed on, and were greatly disrupted to find out that the development team, because the whole thing was like not even in alpha yet, it was still under active development, that the development team was, of course, like, routinely incrementing the node version.
Yeah.
And it's like, this wasn't a user, like it was who's a customer? The customer is someone money is coming from. This wasn't a customer. This was another part of the same organization that money was going to operate these things, and yet nonetheless felt like some sort of implied API contract commitment had been broken. The contract being, we thought you were promising us the system would run on node version N, and then from the client consumer side, like, we made no such promise. We never even contemplated such a promise, much less made such a promise.
Yeah, I had a situation kind of like that from the other end where we were told to use a particular API to get a particular bit of data, and we used it, and it was working fine for us. And then at some point, they said, "All right, well, we're getting ready to release to you the API for that data." And I said, "Well, we already have it." "What do you mean you have it?" And I said, "Well, here's the link. It works." And the people who were providing that data had no idea that URL existed. There's just, we don't know who created that. We don't know who exposed it. We don't know who had told us to use it. And so then we had to take a several month process while, like, they needed us to get off this thing that was working quite well for us. And as they added the new version, wouldn't always work, or would have this problem or that problem. We're like, can we just use the old one? No, we need to get rid of that. It's insecure. We don't even know why it exists. And so, like, we had a dependency that we thought was legit, but it apparently wasn't, and no one knows where it came from.
So I guess a point that snuck out there was APIs are a form of dependencies. And dependencies are always the source of all these versioning issues. So what have we seen work well, though? And so, Paul, you described one thing you've seen work really well, which was the whole system is being, like, deployed from a monorepo, and since it all gets deployed as one chunk, which is not required in a monorepo, but certainly very well facilitated by a monorepo, it didn't matter if you made a change that affected two different parts, because they would get deployed concurrently anyway. So that's one happy path. What other happy paths have we seen through the world of, different teams collaborating on an API evolving over time?
I've seen one that works. I wouldn't say works well, but it works. It gets the job done. And that is that both teams kind of work mostly independently. And then, like, as it comes time to deploy, there's a mad rush of get everyone on the phone together at the same time to work through the problem. And while I hate that approach, and it just makes my skin crawl, it can work.
Sure. I see
can
Chris
get the job
wincing.
done.
Oh, I'm having a flashbacks to working for a certain company I won't name, where we had 1.5-year cycles, and the last 6 months of each 1.5-year cycle was 10 different teams showing up to talk to each other for the first time with their software in the lab. And then, 6 months later, we're trying to get out of there before Christmas, because of course nothing ever works.
Paul, I think there's a numerical constraint on that. Up to a certain number of developers on a certain number of teams, just like hustling up and collaborating intensely toward the end can work. And then if it's enough people and teams that you have a 2-year cycle, as Chris's scenario was, then you're probably past the point where that works well.
Yeah, that's true. Projects do come to mind where no amount of collaboration could fix them. The architectural differences were too far apart. And just like fundamental mismatches of understanding on what problem are we even here to solve.
I have found that the big API problems are not one team liked GraphQL and the other was REST for life. The problems are not one person likes to put their dates in ISO strings and the other likes to put them in Unix epoch integers. Those aren't the real API. The real API problems are the two different things have completely different semantics. Yeah, sure, they're both using REST and they're both encoding dates the same way, but the meaning of the data, I have these set of 10 fields and you have that set of 15 fields, and there is no single field among them that has the exact same meaning.
Or the backend provides data without an actual small, easily used unique ID, and then we need to send that back in. So, all right, I guess we have to send a huge string each time we request anything because there's no easy ID. It has to be the full, file path or something like that. Or the data that they provide is the full data. It's going to be 0.5 mega data, and that's the only thing that they have time to provide. And so it's up to us to do all the processing of it to make it something reasonable that's not going to choke the browser. These are not the types of things you were saying. Yeah.
So you're trying to come up with a way to concretely identify this particular part of the backend we're trying to communicate a change about. And the backend system doesn't even know that thing is an entity that has an identity. It's just that's just a part of a blob I handed you, man.
Exactly.
Here's your blob. Do what you want with it. Don't tell me about what's inside the blob. I don't even know what's inside the blob.
Yeah, and sometimes it's to change something in the blob, and sometimes it's I want to get associated data, but it's just, okay, I want to get data that's associated with this blob. How do you define that? Yeah, it's defining the APIs. Well, in another area that have problems is I was on a project once where we would have a dev and a QA and a prod, and then each layer would have a dev and a QA and a prod, and each layer considered anything on dev could be changed at any point because it's just on dev. And so while we're working on dev at this layer, this layer could change at any moment underneath us, and so could this layer and this layer. So the whole stack, we had nothing that we could depend on necessarily unless we said, all right, we're only going to use prod for our devs, but the prod wasn't ready yet. And so what do you do? It's collaboration issues. It's humans figuring out what works well together. It's not ISO strings.
Well, something I've done to help with the problem with the approach I described earlier, let's all get on the phone at the last minute and work it out, and it actually addresses Lance's particular challenge as well, is I will go off and build my own server. I'll say, you know what, the ground in which I'm building is way too shaky, and no one seems to even understand the kinds of problems I'm having. And I will go off and build my own dev server that is stable, that gives me data in the shape that I want. And where possible, I will pick up underlying kind of constraints that I'm aware of about the system that's being built on. And then when it comes time to reconcile those differences, you're speaking a common language with the backend team. You're talking about, I'm showing we're doing a diff from backend to backend rather than two different technologies and purposes and ideas. It is backend to backend. This is what I need. Yes, mine is simple. It does not have the same sets of constraints and realities that you're dealing with, but this meets my needs. Yours does not. What can we do? And it gives if you have that separate backend team, it gives them a starting point to actually commiserate with you on the challenges that you're trying to solve, and just helps move that process along a lot faster.
Paul, I've used that same thing for kind of the performance question around granularity. It's like, here is a small, simple backend that returns the consolidated set of data that we need to create the proper short response time in this UI. I realize it has to pull data from multiple sources to get that, but here's a facade server that does that over on the server side. Now we can like refactor between that server and the other servers, and we can iterate and we can API version those separately from how we manage version and change between the facade server and the front end. Because in theory, if the front end features don't change, there should never be a reason to change the API of the facade server, right? Like if it's getting all the data it needs to serve the job it's doing, then unless you add another feature, you're never going to need to add another field or change a granularity. And then you have a server-side piece which can be deployed like at a cadence that matches the other server-side pieces to manage evolution and change of the APIs over time.
Yep. And if you're working in this mode where your development is decoupled from the backend, the only time that the versioning matters is on your most recently past deployed version.
Yeah, right.
Another situation I had that Paul's story kind of reminded me of was when it was one of the situations I mentioned where there were different companies that had been purchased, and so they had different data systems. And they didn't know yet how to combine these databases in the relational database. And they gave us a mock-up of the relational data diagram of where they thought they would end up. And it was, I think, 30 tables, something like that. It's like, all right, well, I'm supposed to get this amount of data. And in order to do that, I traced on the map, the joins would have involved like 15, 18 tables, something like that. And I found some spots where like the one-to-many relationships were pointing in the wrong direction. And I wasn't really able to communicate like why these were problems or what the problems, because it was so amorphous. So I ended up creating my own mock backend in Postgres and creating all the tables. And then I showed them like, and that's what we used for a while in our databases. It was still a prototype, or for our application when it was still at the prototype level. But once they saw the SQL, then they were able to think about it as SQL and see some of the problems that were there. And it also, I think, gave them a framework to help them pull the things together. And eventually we had a real API to go with, and we pointed to that instead. But even being able to, as a front-end developer, know enough SQL to be able to cobble together the joins to get the 16 tables together to show this is how onerous the structure is, because this is where the data is, it opened a few eyes. And some of those GraphQL queries were pretty ugly because of all the chaining. So figuring out how to do that right was rough.
I just love that idea, Lance, of like traverse some of the gap yourself to try to be able to work with another group or another team better. Like, don't just sit shouting each other across the void. Like you're describing is you cross that void yourself to go like, I'm going to come over here and help work it out over here. I'm not going to force you to try to talk my language.
Yeah, I think it may have given us credibility for quite a while that we were able to create a database structure for them. I'm not going to ever claim that it was well optimized and that I'm a great DBA, but the fact that we were able to start talking their language, I think helped our credibility.
Just getting the relationships right. Like, is this a one-to-many? Is this a many? Like, what is the relationship between these two entities? Being able to have that conversation concretely can help so much. Well, I guess my only remaining topic, I guess I didn't, it's not on the one that I pasted in yet, and that was, do we have anything to say about like any other the sort of team dynamics, interpersonal parts of managing this kind of collaborative building of multi-tiered systems across APIs? I'll go first and take the low-hanging fruit, and that is to like always remind ourselves that like we're all on the same team, even if that other team over there is griping about an API version. Fundamentally, if we're all like working for the same parent organization to try to deliver some system, then we're all in some sense on the same team, even if we're on different teams.
I would take that one step further though and go so far as like well, yes, we're on the same team, but also consider those that use your code like as a true client. Like there's nothing so special about your code that like the way you want to do it or the way you think that you have to do it is more important than it being useful downstream.
Yeah, that's great.
Like doesn't matter how well written it is. If no one uses it, then it's no good.
Yeah. I mean, I guess we aspire at the best case for the work we do to be art. But in a realistic way, it is mostly a thing of practical value to another person.
Yeah.
Well, I'm all out of steam on this topic, which we've now talked about for over an hour, which I think is pretty good. Anybody with any closing comments, or are we ready to wrap up and send our handful of viewers on to the rest of their day?
Good luck. People problems are hard.
Yeah. Yeah. This issue is something that I'm working through on my current project a lot, and it's just doing these collaborations, and a lot of my previous projects a lot. There's different structures, different ideas. No matter how much people document what the APIs are, there's still confusion, at least in my experience. It's not easy.
You can make software talk to one another. You can't make people talk to each other.
Chris, anything final from you?
Just people need to be flexible. There's
Yeah.
so often it's like the person in charge is like, this is the way things are always done, and they're enforcing, because as we talk about, like, the strategy may differ based on the context, and too often the people in charge have a very set idea about this is the one way, and
right.
So, no flexibility there.
We've always passed our dates without time zone information, and it's got us to where we are today, so it'll take us wherever we need to go in the future. Okay, well, I guess thank you to our viewers, both live and a much larger number typically of later viewers. And I guess we will catch you all in the next episode.